Hello everyone, welcome to the Amazon Web Services training session introduction. Today we're going to talk about what AWS is all about. Why is AWS so demanding in the job market? What makes it so demanding? What will be the course contents as part of this training session? So I'm sure by the end of the session you will have a fair to good understanding of what AWS is. So let's get started. Cloud computing. This has been the buzzword since the last few years. So, what is cloud computing? But before we getting into that, let's try to understand what a local data center facility is. I'm sure all of us use these applications like Gmail, Facebook, Twitter, right? So those are all the applications, and for them to be hosted somewhere, they need an infrastructure, right? An infrastructure that contains server, storage, network, and a lot more other devices. So that's a local data center facility. Facebook has their own, Twitter has their own. So all these big organizations, right? They need a data center with all these hardware components plus software components to be able to run their application. That's a local data center facility, right? Now think of moving that whole local data center facility to somewhere else, which is to someone else's data center. So instead of a company having their own data center in-house on-premise, they will actually use the data center facility that is built by someone else. And that someone else is called a cloud service provider. So a cloud service provider like Amazon will build these huge data center facilities around the globe, and we as customers will host our application on their data center. So instead of having your own on-premise, you are hosting your application in someone else's data center, right? So that data center to us is cloud, because we are not keeping our own devices, right, in-house on-premise. We are using someone else's devices to host our applications. So that's cloud. Now, the word computing means you have all these hardware components, right? Like the server, storage, network, they all have computation that they do because your application, you try to access the application, you try to, maybe upload your photos to Facebook, download photos, interact, with multiple videos. So all of these, right, constitute for having computation. They need computation. So these data centers that are held by like cloud service providers, they provide the computation platform in their cloud. So that's why the word cloud computing. Also, the other key thing about cloud is that is something that's outside, and all you need is internet to be able to access it. Okay, so the data center that is holds by these cloud service providers could be anywhere around the globe, and all we need is an internet connection to be able to connect to it. As you can see right here in the picture, this is a cloud. Well, the shape is cloud. You got the servers, storage, and the networking components right there. And we can access, if the application is being running on these, you can access them from your computer over the internet. So that's how cloud computing works. Is you have your application out somewhere, and a user or a customer or an organization can access those resources from that cloud to be able to compute along with the application. Okay. What is the need for cloud computing? I mean, we've had all these data centers locally since decades, right? I mean, a lot of our nations used to have all these. I mean, they still have. So why is there a need for cloud computing? Why is there a shift in moving towards cloud computing? Right? I mean, if you remember those days, it started off with a small computer spanning across multiple rooms, right? And then the mainframe decade has started, and then the AS400s, and now you have data centers that are set for each organizations in their on-premise, and that's been continuing since a few decades now, right? So what is the need for that shift? So let's take an example to compare that. Let's say there's a company that is being newly set up, and they want to also, have an on-premise data center. So for them, capital cost is something that you gotta make sure you have with respect to setting up the infrastructure, because you need to set up the facility, the whole area for your data center. That's a lot of cost. You need to make sure that facility is built with enough power, cooling, redundancy, generators, the floor cabling to be done in such a way it supports, the cables to be connected across devices. um, you gotta buy server, storage, network, devices all upfront. That's a lot of capital cost. Plus, you gotta hire resources to be able to manage the respective domains, right? You gotta have one resource who can manage the servers, one resource for storage and backup, a network engineer, and you gotta have support for them 24 by 7. So you gotta have multiple resources. All that accounts to operating cost. Plus, you gotta buy the software licenses. You gotta manage patching. You gotta make sure production support is available. So all of this, right? That's a lot of cost, capital plus operating. So these sometimes, right? You don't really wanna buy so much, but then you end up buying because of the configurations. There are certain configurations that are set. If there's a storage array, you only need 5 terabyte of capacity, but because how that storage array is set up, you gotta buy 10 terabyte. There's no other way. So all this, right, will add up to your cost. So, and companies are thinking about how to cut down their infrastructure costs for good, right? What would cost them $1, now they want to reduce it by 20%, 30%. So all of this is what is driving companies to shift to a cloud computing model. So what are the benefits of cloud, right? Why is cloud computing preferred these days over the on-premise data centers? It is secure. Yeah, I there is this misnomer with a lot of people that cloud is not secure because we are putting our data, our company's, very important asset in someone else's data center. So there is a potential possibility that there could be data breach, and the data could be compromised. That's not totally true. I mean, there are so much stringent audit compliance requirements. There are these security standards that these cloud service providers need to follow to ensure there is data security. Okay, and even the governments are being very strictly following all this and making sure they follow that. Plus, there are a lot of modules and customizations available with each cloud service provider that you can tune with. You can make sure your server is only accessible from this IP, or it is only accessible if someone has this key that he can use to log into the server. So there are multiple mechanisms, multiple authentication systems that you could also use, like multi-factor authentications. All of these will make it secure. Okay. Software updates. All maintenance and updates will be carried out by service provider. Absolutely. I'm sure you face this. patching process, right? When you have like thousands and thousands of servers in an environment, and you start the patching with one server, and you know keep going with the other servers, you know that during patching you gotta plan with your application teams very closely, and then just coordinating that whole thing could take a good few number of months. It's like there's a new version release, and then you started patching with the first server, and by the time you end up doing the last server, there's a new version already, right? So you gotta keep patching, and then that means sometimes you gotta have a dedicated team to just support that patching, and that's not the case with when you go to cloud, because all the software updates is handled by that cloud service provider. You don't have to manage, or you don't have to worry about it, right? Even though there are, let's say security vulnerabilities and they need to be fixed, they simply can be addressed by the cloud service provider itself. So we don't have to worry about, hey, applying a patch or a security vulnerability fix. Okay. Flexible, yes. Cloud is flexible in terms of scaling up your resources or even scaling down or shrinking your resources. As an example, let's say there's a new application that you're introducing in your, with your company, and that application needs 5 servers. So you bought 5 servers. This is on-premise data centers. So you bought 5 servers. You've started using the application. Immediately you realized, hey, this application is getting very popular. I need 5 more servers. That's not easy enough to, just get those 5 servers like by tomorrow. That's not possible, because you gotta, get the approval for buying those servers, and you gotta buy those servers. The vendor needs to ship those servers to your site, and then you got to install the operating system, the application, and then you are ready. That could take good few number of weeks, even if you expedite it. Versus if in Amazon Web Services you need 5 more servers, you bought 5 servers and you need 5 more servers, it's just a matter of few hours, and you'll have those servers, because all the infrastructure is pre-provisioned in their data center. All you gotta do is ask for more. They already have. So it's very easy to shrink up, even scale up. Even shrink down is easy. Let's say you realize that you don't need those 10 servers anymore, right? If in your on-premise data center, you want to give away five servers that you bought additionally, that's not possible, because you already spent the capital cost on it. You already connected to your network. They're already running. You shut it down, but still you have already paid for the capital cost and the maintenance cost, right? But the same thing with Amazon Web Services, you don't need 5 servers, shut them down, and you're not paying a penny for those servers. Yes, that's how it works. So that helps, with the varying workload all the time. On the other hand, it helps control costs, because it's a pay-per-use model. You only pay for what you use. And there are different measurements that, these cloud service providers do based on number of CPU cores that you have, memory that you have, the data transfer that you're doing from and to the server, the software licenses, of course, the storage that is allocated or the storage that you have written to. So all these factors, right, they accumulate to what will be the cost. Plus, since you're not putting up the capital cost, it's only as what you use, you pay. You always have flexibility to shut down a virtual machine in Amazon and don't pay for it, you know. And you could always change your configuration. Let's say you initially thought you need um, a very powerful virtual machine with a lot of CPU and memory, but then you realize, hey, I'm not using this virtual machine as much, so I really don't need this much of power. I should shrink it down to a lower virtual machine configuration. Obviously, the higher virtual machine configuration costs you high, so when you shrink it down, your costs are reduced. So This is all the benefit that you get with cloud computing and cloud service provider. Collaboration. Since this is set up across the globe, you have different data centers across the globe, and all you need is internet to be able to connect to that application and then start using it or the server. That means employees can sync up and work from anywhere. They're not now bound to come into the office or connecting to your virtual private network, that your on-premise data center, to be able to work. They can be anywhere around the globe. All they need is internet connection. It provides stability. Again, there has been this misnomer about, is the data stable? Is the environment stable if I move to cloud? Yes, because they plan for it, right? Depending upon how critical your application is, you could also pick and choose. If you need, data protection from a whole data center failure standpoint, they can provide you. So even if one of their data center fails, they can still support your application. Your data will not be lost. So they have different, you know, piece models that you can pick and choose from depending upon the criticality of your application. It provides mobility, so yeah, you can work anywhere, anytime. Then you can move your workloads from one data center in US to another data center in India that belongs to Amazon. Let's say your customer base was initially in the US, but now it's shifted more towards India. You can move your infrastructure because they have data centers around the globe, and we will see that map here in a few minutes. So these are all the benefits of cloud computing. Okay, let's talk about some of the cloud deployment models these cloud service providers provide. The first one's private cloud. Private cloud could either be the on-premise data center. Now, don't be amazed why we're calling a local data center as cloud. Um, it's still a cloud, a private cloud, because you still are providing the application, the infrastructure service for it to run, right? So it's still a cloud, but it's a private cloud. The other definition of private cloud is the cloud hosted in the cloud service provider's data center. Now, in this model, due to audit and compliance requirements, you got to dedicate resources for a particular organization. So, if you have a storage array, that storage array will be completely dedicated for that organization. So instead of they having their own on-premise storage array that's dedicatedly used for them, they will have the same storage array dedicated in the cloud service provider's data center. Okay. Now that could be due to audit requirements or compliance requirements or security requirements, whatever it may be. They dedicate the resource, and that storage array is not shared by any other company, organization, or individual user. So it's dedicated for them. That's a private cloud. Public cloud. The name itself says public, which means any company, organization, or individual user can share the resources. So if there's a storage array, that could be shared by tens and hundreds of resources, and there is no restriction. Hybrid cloud. This is a combination of both private and public. Okay, so even though you have a lot of applications that will move to cloud, there will be a few applications that are not meant for cloud, so that they have to stay in your local data center facility. So that combination of having a few applications in your private data center, your private cloud, and a few of them in the public cloud, like Amazon, is hybrid cloud deployment model. This is what you would see for the most part with a lot of organizations. The community or the government cloud is, let's take an example. Let's say you got Microsoft. Within Microsoft, you got these different divisions: the hardware division, the software division, the commercial products division, like the mobile phones. So let's take these three divisions. Now, all of them wants to share a particular resource, let's say a storage array in the cloud, but then they don't want anyone else to touch it. So only those three divisions should be using anything from that storage and no one else. That's a community cloud. So community cloud is if a device is only being shared across certain set of customers and no one else, that's a community cloud. So you have all these deployment models supported by Amazon Web Services. Now, the most famous is obviously the public cloud. One, due to its cost, and two, due to its flexibility. And we'll talk more about the other cloud features, expanding onto these in our actual course. So these are the different services that are provided by cloud service providers. You got infrastructure as a service, you got platform as a service, and software as a service. Now you also got private cloud. This is your internal data center, and all these boxes here represent each layer. You got networking, storage, server, virtualization, which encompass the hardware layer. Then you got operating system, Windows, Red Hat, Linux, AX, Solaris. Then the data that you have to store that comes from the applications. So in an in-house data center, obviously, all these components belong to the customer or the organization who owns it, right? And that's your private cloud. So all these are under the company's control. They are the the go-to and the owners for everything. In the second model, infrastructure as a service, this is what your cloud service providers provide. You have network storage, server, and virtualization that they provide, and the remaining ones is something that we got to have control over. Okay? In platform as a service, all these hardware plus the operating system also is provided by the CSP, cloud service provider. We have control over the data that we write and the applications that we want to run. Under software as a service, everything is under the cloud service provider's control. So all we use this software as a service. Everything is managed by them. So let's talk examples. A good example of infrastructure as a service is all you need is the infrastructure to run these infrastructure, and you are responsible for installing your own operating system. A lot of times, right, we don't use the vanilla operating system that comes from these vendors. Let's say a Windows 2016 server OS has been released, we just don't deploy it directly. We have our own standards, right? Every company has that. You try to modify the registry, the security settings, sometimes the functionality of the OS to limit a few things, which will suit your company, right? So you'll have your own custom Windows OS image. So if you want to deploy the same custom Windows OS image on the cloud for your servers, you need control over your operating system. And that's what infrastructure as a service provides, the control over the OS. You deploy what image you want. Then the data and the application is also under our control. So we get to decide what application we want to install. That's infrastructure as a service. Platform as a service. In here, apart from that, the OS is also taken care by the CSP. So you don't get to upload your own OS image, but you have all the varieties that are out there in the market. Windows, Linux, Red Hat Linux, different other variants of Linux. You got other canned operating systems also all built in. So it's like a menu card that you can choose from. Okay. So when you go for platform as a service, the server comes installed with the OS that you pick. And all you got to work on is which application should I be installing, how do you set up the data, in and flow, all of that. That's why it's called platform as a service. Then you got software as a service, which is, let's take an example. Let's say you got a company with 100 employees and you want to set up Outlook for them, an email client for them. So instead of deploying your own Exchange server internally, you can go for cloud. So what you could do is you go to a cloud service provider and say, I need 100 mailboxes, one for each user, so that they can exchange emails. So now the software is not residing in house. None of the servers are residing in house, but you're using the Exchange application, the Outlook application as a service from the CSP, right? So that's software as a service model. Similarly, you got a lot of other software as a service models. Amazon provides a lot of them. Lambda is one that they provide for. Just all you got to do is use it for code, applications, etc. It's all pre-built. Microsoft also has some of the famous ones like the Office 365, where they provide the entire Microsoft Office suite as a software as a service. Okay, so every service has its own use case. Sometimes you want to have control over your OS, sometimes you don't. Sometimes you want to have control over your application, sometimes you don't. You just want to use it as a service. So depending upon your requirement, you pick and choose what you want. And Amazon Web Services has all these service. Now, one of the famous cloud service providers, of course, the pioneer is Amazon Web Services. That's top in the market, followed by Microsoft Windows Azure. And there are other players like Google and IBM. Salesforce.com is another big one for SaaS model, the software as a service. So these are all the major players. Now you may be wondering, hey, why is YouTube, Yahoo, and Flickr there? Though they are not providing you like an infrastructure as a service and platform as a service model, they are SaaS. Okay, because YouTube allows you to upload your content. So you're using the YouTube application that is hosted somewhere else for uploading your content. So you're utilizing it, right? So that's software as a service. Similarly, Yahoo and Flickr. So they still come under a cloud service provider because of that. But the most famous ones that are used by enterprises for a lot of their application deployments and enterprise applications is like Amazon Web Services, Salesforce, Microsoft Azure. Now we discussed about Amazon having data centers across the globe, and here's the spread that you can see. You have it right from the America to the Europe to Asia Pacific to Australia. So pretty much encompasses the entire globe. Now the green circled ones, they indicate the regions that are yet to come. Okay, so they are either in the process of being built or very close to completion. So very soon you will see those turn into the orange rings, which is the ones that are already built. So the orange rings represent the ones that are already built. So you can see there are a lot of data centers around the globe. There's one in India also, in Mumbai. Now the reason they're spread across is, let's say you have an application that is more regional, like let's say India. And if the majority of the users are in India, it definitely makes more sense to have the application hosted in India rather going to the US every time you want to access the application. Obviously, I mean, no one can overcome the law of physics, right? If it's thousands of kilometers away, it will take some time. The access time will be a little slower, right? Relatively. So to even overcome that, why don't you have one locally? If you have one locally, why don't you host the application there, right? So that's in fact one of the important consideration with cloud is you got to know where the user base is, which site, which location is the best optimized for your application. You need to you know understand that requirement. Okay, that's about the AWS regions. So here are the names, which cities or which locations have these data centers. Like I said, the orange ones, the ones that are already built. The green ones are the ones yet to come. Okay. So just to sum it up, Amazon Web Services also provides certifications there are two certifications that you can target as part of this course. One is the AWS Certified Solutions Architect. The other one is the AWS Certified SysOps Administrator. All the course contents are laid in accordance with that. So we will be covering topics that you would get in that certification. And I'm going to go through the course contents here in a moment. Before that, with respect to the job market, I'm sure you've done your enough research. So there's already a lot of jobs there, and plus it's growing because more and more companies are starting to realize the benefit of cloud. Now, again, I say this, I think I've said this a couple of times. Not everything is going to move to cloud, but there will be applications that are best suited for cloud, especially with more and more customers around the globe getting access to the internet and the social networking applications, the mobile applications growing. So with all the advance in those technology arenas, cloud becomes a very key resource for technology development and companies growth. So yeah, it's gonna grow more and more. In fact, I've heard this in a survey that in the next 7 to 8 years there will be more cloud jobs than anything else in the IT domain. So getting familiar with this is going to be critical for everyone. Now, with respect to the prerequisites of hey, am I ready for cloud? I would say yes, both for freshers as well as people who are already into IT. So we look at two different aspects, right? So those who are freshers, since you are new, and that's an advantage because you're coming with a fresh mind. And then all you gotta know is how do you deal with the console? How do you understand these concepts? Just get around some of these things. Now, don't think that people who are already in IT have a full, complete advantage. Maybe to a little extent, but not a lot, because the way IT is managed in house and the way IT will be managed in cloud is different. Okay, so it's gonna be new for everyone. It was new to me when I initially started, so it will be new for everyone. Okay, now with respect to the people who are already working in IT, I mean, if you already are in infrastructure, great. It will help you to an extent, but then it's gonna be different too. So you gotta prepare yourself that it's gonna be different, and you're ready to absorb it. Okay, so there is no prerequisite completely. I mean, all you need to know is I'm sure everyone here understands computers, desktops, just a few, how the network connects, things like what is storage, things like that, right? So that's enough to get started because I am going to assume that you um, don't know a lot of about IT and start the course that way. Okay, and I will try to make sure everything that we talk about is not just what's in those presentations or PDFs. It's about me sharing my experience with you because I believe in learning from experience. So I hope you guys do. So let's quickly hit the course contents here in a second. Let's see what we cover and we can conclude from there. All right, so this is what the course content is: the introduction to cloud computing, then the overview of AWS, and then the different modules that you have in AWS. This is one of the most important ones. This is where you build all your servers, the Elastic Cloud Compute or EC2. The load balancer is responsible for both high availability as well as improving the performance parallel. CloudWatch is a monitoring and alerting service, becomes very important because you may have hundreds and thousands of resources to look into, and just manually monitoring each of them is so tiresome, right? So you gotta have something more proactive along with alerting. So this is the tool. Simple notification service for sending out notifications. Relation database service, you got to know how to set up the databases in the cloud, what kind of database you have, how the licensing works, those kind of things. So that will be covered in that module. You got auto scaling. Auto scaling is very, very important because let's say you have this workload that you run once in a week on a weekend. Now, when you turn on auto scaling, AWS understands that, hey, this weekend, this more high load is going to come up. So I'm going to build 5 more instances of the same application to handle that load. And then once it's completed, then it will shrink it down back to 5. So, I mean, that's the advantage, right? You don't have to be provisioning resources every time, and you won't run into any issues with slowness because it's automatic scaling it. More to come, more to come there. So we'll discuss more there. Simple storage service is the storage layer in Amazon. This is where all the storage will be set up and stored in. Then you got Glacier, which is a subset of the AWS storage layer. It is meant for archiving purpose. AWS CloudFront helps boost the access between the customer or the client and the application. So let's say your application is hosted in the US and a client from India is trying to access it. Now going over the WAN for that long is going to be slow, right? But these CloudFront setup will help boost that, and it feels like as if the application is within the same city or within the same country. Simple email service, name itself says. Identity access management. This again is very important because one of the misnomer about any cloud service is that security, right? It's what about our data? So with IAM, you can set up things like making sure no one else can reach that server or no one else can reach that database, right? You lock down all the ports, you lock down all the IPs. If someone wants to connect to it, you can set up multi-factor authentications. So all that helps uh, maintain security. Virtual private cloud, since you're building your own virtual small data center in the cloud, it's very important that you draw boundaries. Otherwise, anyone will enter. So VPC helps you do that. So we'll talk about that also. Cloud formation. This is like a small workflow designer tool. If there are tasks that you repeat again and again, so instead of doing them manually, you can put them into a workflow and then try to finish it together. So cloud formation will help you there. CLI. For the most part, a lot of people use console, but if you want to use CLI for a few tasks, especially if you want to run some automated scripts and automated steps, you can very well use AWS CLI. The best practices will be covering about cloud optimization. How do you optimize the resources in your cloud? Cloud migration, if you ever have to migrate from in-house to cloud or from cloud to in-house, whichever direction, you got that. Third-party tools for health and billing monitoring. It's very important that you know how to monitor the health of all the resources plus the billing aspect. Because keep in mind, for everything that you do in the cloud, you're gonna be billed for. Okay, so you got to be careful, understand what you're built for, so you do the right things. Okay. Alrighty, so with this we mark the completion of AWS introduction. Thank you so much for attending, and hope to see you soon. Have a great day.